So we are continuing the statistics. That's part one of statistics. That is statistics. I hope my spelling is correct. So another statistics. Uh, I'm coming there. So we are doing statistics. I think in our previous lessons we studied. We first started studying. We first introduced ourselves to statistics. We defined what statistics itself is. We looked at that, and from there we looked at the various terms associated with statistics. We had to talk about the discrete data, the continuous data. We spoke about frequency, spoke about frequency distribution tables, and so on and so forth. We spoke about the tally tables, and we now looked at grouped and ungrouped frequency distribution. We looked at the group frequency distribution. We looked at the class size, the class width, midpoint. We looked at all these things. We looked at bar charts, histogram, what do you call it, bar and the rest. We looked at all these things, how they are done, calculations, how they are calculated, and so on and so forth. Today we will finish. By God's grace, we should finish for the first part of statistics. Then next week we start with the second part of statistics. That will have to do with standard deviation, mean deviation, variance, and so on and so forth. I think that'll be the last part. Then we are done with that. I'm aware you've been taught probability by Solomon, so I don't want to go there. So we are going to consider something. We are going to talk about. We are going to talk about something called measures of central. If you can't hear me, humbly tell me. Central tendencies. Measures of central tendency. That's what we are going to talk about. Measures of central tendency. And under the measures of central tendency, we are going to talk about the mode, the median, and the mean. So under this, we are going to talk about the mode. These are the central tendencies we are going to consider. We are going to talk about the mode, the mean, how to calculate for mean, and we are also going to talk about median. So that is it. Now, it is observed that most of the terms in data seem to be crowded in its central part. So most of the terms in the data are normally considered to be crowded in its central part when the data are arranged in increasing order. So we realize that when data are arranged in increasing order, there may be circumstances where we are going to find a huge number of data. There are some instances we are also going to see one of the numbers reoccurring plenty and all these things. Now, the tendency of the observations to cluster in the central part of the data is what we call the central tendency. And under the central tendency of the data, we are going to talk about average, which will have to do with the averages of these central tendencies. We are going to talk about the mean, we are going to talk about the mode, we are going to talk about the median. We first start off by talking about mean. Now, who can tell me a little bit about mean? When we say we are finding the mean of a set of numbers, who can tell me how do we do it? Just a basic calculation of mean. In other words, some call it average. Who can tell me how we do the calculations? So for instance, if you have a set of numbers, let's say S1, X2, X3, X4, X5. If you have this set of numbers and you're asked to find for the mean is given by X, there's a dash on top. So X, there's a dash on top. So let me just, because of the dash, let me put this thing. So this will be my mean. So mean is equal to, how do we calculate it? Before you can be able to find for the mean is more or less like calculating for the average. So the first thing I'm going to do is you count the number of the variables you have here, or the numbers you have here. So this is 1, 2, 3, 4, 5. So it is 5. So I have 5 variables there. Now from there, I'll add all of this and I'll divide by the number or the quantity of the variables there. So this one will become, my mean will now become x1 plus x2 plus x3 plus x4 plus x5. That's what I'm going to now divide by the number of this, what you call the n. So I divide by n. Here the n is 5, so I can just write 5 divided by 5. I hope you are getting it. So in other words, I can now say that our mean can be defined as the summation of this all over the number of this. So I can say that my n is equal to sigma. Let me see if I can. So let me just use this. So I can just write it this way. So my mean will be equal to sigma of x, right? Sigma of x values. The addition of all the x values all over n, where n is the number of, what do you call it, the x values. So the mean, that's the simplest way of finding for a mean of a data like this all over n. I hope you all get it. You all get it?
Yes, sir.
Okay, so let's try this in your books. Find the mean of the following set of numbers. Find the mean of the following set of numbers. Find the mean of the following set of numbers. Number 1, 0. Number 2, 0, 2, 0, 2, 3, 4, 5. 5 and 4. And 4 again. Find the mean of this. Find the mean of this. When you finish, you find this one. 3, 9, 11, 2, 9, 28, 37, 20. And finish, do this for me. What are you getting? The first one, what did you get?
3.
3, okay. The second one, what did you get?
80.
8, okay. Now let's do this one too. The average of 5 numbers. The average of 5 numbers. The average of 5 numbers. 4, 4, 10, 24, x, and 16. And 16 is 13. It's 13. So the average of these 5 numbers, are 13. Find the value of x. Find the value of x. Find x. Find the value of x. Find the value of x. You are doing it.
Sir.
Yeah.
Sir, please, I had 11.
11. Who else? Who else? Who else? You also had 11.
I also had 11.
Okay, great. The answer is 11. So you add all of this, you divide by 1, 2, 3, 4, 5. You divide by 5, then you equate it to what they call it 13. Now let's do some more examples. The average age of a class of 20 students. The average age of a class of 20 students is 15 years. The average age of a class of 20 students is 15 years. The average age of class of 20 students is 15 years. And the average age of another class of 30 students is 20 years. And the average age of another class of 30 students is 20 years. Find the average age of students of the two classes. Find the average age of students of the two classes. So let me reiterate the question. The average age of a class of 20 students is 15 years. And the average age of another class of 30 students is 20 years. Find the average age of students of the two classes. Start, do it. What do you get?
18.
18. Who had the answer? Who had the answer?
18 years.
18 years. Okay, that's correct. Hey, there's your being. Now let's do some last one there and continue. Okay, the ages, the ages, the ages into bracket in years, of 5 men are, the ages into bracket in years of 5 men are 48, Y, 52, 50. and 2y minus 5. Let me take it again. The ages in years of 5 men are 48. So the first one is 48. 48. 48y. 52. 52. 50. 50. 50 and it's a bracket 2y minus 5. Oh, 2y minus 5. I was supposed to write 2y minus 5. Find the age of the oldest man. And sorry, if their average age is 47 years. If their average age is 47 years. If their average age is 47 years, find the age of the oldest man. If their average age is 47 years, find the age of the oldest man. Find the age of the oldest man. Find the age of the oldest man. I hope you got the question.
Sir,
Yo,
if I don't get the question before this one,
which question?
the average age of a class of 20. The
Okay.
average age of a class of 20 students.
Students. The average age of a class of 20 students, not as 20, of 20 students is 15 years. And the average age of another class of 30 students is 20 years. Find the average age of students of the two classes. Is that you don't get the question, or you couldn't solve it?
Yes, please.
Okay, so let's do it. But we have a pending question too. When we finish, we'll do that one. So we said that the average age of a class of 20 students, so class A, let's say class A, that's how many? Class A has how many? It has 30 students, right? Or 20? 20 students. 20 students. And the mean of that, this thing, mean is, or the average is what?
15 years.
15. Okay. Number 2, we can also talk about what? The other one, it says, the average of another class is 30. So class B is of 30 class. M is what? It's 20 years.
20 years.
Okay, so find the average age of students of the two class. So the sum of ages for the class of 20 students. Before we can be able to find the sum, the average, before we can be able to find the average age of the students of the two classes, we are supposed to find for the total age. In this case, we are given the, what do you call it? We're given the mean ages of the class of the people, the mean ages in each of the class. Now, before we can be able to find for that of the mean of the two of them, we first have to find for the total ages of students here, and we are also supposed to find for that of students here, and that will give us. Then when we finish, we go and find average of it. Then we are good to go. So basically, that's what we are going to do. So the first thing we are going to do is, well, that's why we are going to multiply this by 15. I'm going to multiply this by 15. That will give us the total age of the students, the 20 students. When we finish, we are going to do same for this one. Then now we can talk about the average and so on and so forth. Have I made myself clear?
Yes, please. Thank you.
So so this one will be 20 by 15, right? 20 by 15. What are you getting?
300.
300. And this one, what are you getting?
600.
600. So we have this one. We have 600. So when we finish, we want to find for the average of the two classes. So before we can be able to find for the average of the two classes, what do? We just have to add the two classes. Do you get it? For instance, if you want to find the average of science 1 and science 2, we have to add the number of science 1 and science 2. When we finish, then we find the average. Are you getting
Yes,
it?
sir.
Yes,
Yes, please.
then what we are going to do is science 1 is let's say, so now we know science 1, the ages in science 1 are 300, and that's in science 2 are 600. So now we can get what, 900. When finished, we have to find
Yes,
for the
please.
quantity, the summation of the quantity of the two classes. We are aware that in science 1 they are 20 and in science 2 we are 30. So that means, we have how many? We have 50. The number is 50. Now, what we are finding for this
Yeah.
thing, the mean into brackets x will be equal to the summation of the two classes all over the number of students in a class. So this we can get 900 all over 50, and that should give us our answer. What are you getting?
18.
18. I hope everyone gets it. I hope you get it now.
Yes, sir.
Please. Thank you.
Okay. Now let's do the second one I gave you. The one I just gave you. The one I just gave. Who is done with that one? Yeah, Ruben, talk to me.
Sir, please, I had the age of the oldest man to be 55.
Okay. The age of the oldest to be 55. I had which one again? Okay. It's 55. Who else? Who else? Who else? Who else? Who else? Who else? I hope you also had
I have
55. Oh,
55.
okay.
Yeah, 55.
So I presume we are all able to do it.
Mm.
Oh,
Yes,
okay. Glory be to God. So you are just still going to use the same formula now to do it. So let's box on. We are still doing mean. So the first one we did was calculating mean of an ungrouped data. Now we are going to calculate for the mean of a group data. So now the first thing, the second thing we are going to do is number 2, calculating the mean from a frequency table. Mean from a frequency distribution table.
But is there another one?
It's still under mean. It's still under mean. So we are going to now consider calculating the mean from a frequency distribution table. That means when you are given a table of x values and their frequency, when you are given a table of a set of values with their corresponding frequency, how are you going to calculate for the mean? That's what it means. I hope you are there. So for instance, all those who joined the class in our previous meetings, I spoke about frequency and so on and so forth. So that is it. So for instance, if I have a table like this, so when we have something like this, okay. We can have, I'm just trying to draw a table. Now, so you know that in a table, you will definitely have our x values. So, understand. So here we have the x values or the class mark or something. We can talk about that. We can also talk about the frequency. Then, so this is what we have. Now, when you are given data like this, there are some instances they won't give it to you in a table form. We'll just give it to you in a writing form. So number one, you would first have to put it in a table form, and now you come and find for the mean. So this is a frequency. There's a mark. So for instance, if they give you this value, so let's say this is 1, 2, 3, 4. Then maybe the frequency of one. This is maybe 5. Maybe this is 2. Maybe this is 6. Maybe this is 10. These are their frequencies. Now, the formula is given by calculating the mean for the frequency distribution table. Sigma, which is the mean, is given by the summation of fx values. Fx, summation of fx. This is not f of x, so this is fx values all over the summation of the frequency. So this means that when you are given something like this, when you have a data like this and you want to find for the mean, the first thing you have to do is you first have to find for the fx values. When you finish, this is sigma, which means summation. This is a summation sign. So what you are going to do is you first find your fx values. So fx. Now, having found your fx values, this is f times x. So this one will be 5. This one will be 4. 3 times 6 will be 18. And this one will be 40. As I'm getting this, we've been asked to find for the summation of f of x. So I'm going to add the whole of this. So this will be 9. 9 plus 58. What was the mark? 9 plus 58 is what? 67, right?
7.
67, right?
Yes, sir.
Then we are going to add the whole of this. What are you getting? 5. This will be 7. 7 plus 6 is 14. Hey, no, 13. 13 plus this, so this will be 23. So if I'm to find for my mean will be given by this is equal to 67 all over 23. So this will be my mean. You can write them in decimals. That is it. Well, you know that the f is the frequency and the x is the class mark. I've already spoke about this. There's some instance you may have to use the midpoint or something to do it. That's when we are talking about the ungrouped frequency and so on and so forth. You may have to use this thing. When you have an ungrouped frequency, when I say ungrouped, do you know the ungrouped? So this method is usually used when we have an ungrouped frequency distribution. We will do all these things. In this case, S represents values. We will do all these things. So let me just give you one to try. So in a workshop, we are writing in a workshop, the times taken by 120 trainees in a workshop, the time taken by 120 trainees in a workshop, the time taken by 120 trainees to identify a fault in a machine are shown in the table below. Find the mean. In a workshop, the times taken by 120 trainees, found by 120 trainees to identify a fault in a machine are shown in the table below. Find the mean. So the table, draw two tables. First one, write number of minutes. The second one, write number of trainees. First one, write number of minutes. The second one, write number of trainees. Now, the number of minutes, the first one is 1. The number of trainees is 2. Its corresponding number of trainees are 2. So I'll just say it. So 1, 2. So 1 for the number of minutes, 2 for number of trainees. That's how I'm going to pronounce it. And the second one, we have 2 and we have 3. That's 2 for number of minutes, 3 for number of trainees. That's their corresponding. And let's take note that the number of trainees becomes the frequency, and the number of minutes becomes the x. So the first one is 1, 2. Then I have 2 and 3. Then I have 3, 5. I have 3, 5. 3 for number of minutes, 5 for number of trainees. Then I have 4 and 10. I have 4, 10. Then I have 5, 15. 5, 15. Then I have 6, 30. I have 6, 30. I have 6, 30. I have 7, 25. I have 7 and 25. 7 for number of minutes, 25 for number of trainees. Then I have 8, 15. 8 and 15. I have 8 and 15. 8 and 15. Then I have 9 and 10. I have 9 and 10. 9 and 10. I have 9 and 10. 9 and 10. Then I have 10 and 5. I have 10 and 5. So let me repeat them again. So I have 1, 2. I have 2, 3. I have 3, 5. I have 4, 10. I have 5, 15. I have 6, 30. I have 7, 25. I have 8, 15. I have 9, 10. And I have 10, 5. So let's do it. Let's do it. So we have to find for what do you call it there? The mean. Who is done? Who is done? Who is done? I'm waiting on. So why are you tell me? When I catch you, start again. Yes.
She says 753 over 127.
Yes, 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 yeah. Yeah, what?
I had
You had what? 6 points.
275.
275.
Okay, correct. The rest will end. So when it ends, you join again so that we solve one or two questions. Then we do another. You continue. I want to finish the first part of statistics today. You said
I run the 7, then it becomes 6.3 or
yeah. So it will be 753 all over.